Thank you so much. That was wonderful. I really enjoyed it. Still don't understand partial differential equations, but
save it for next encounter.
The slide about 2 or 3 back of the wastepaper basket, it reminded me of a joke that I heard a few years ago about a particle physicist who went to the dean of his university and said, we need a new accelerator. And the dean said, okay, here we go again. How much is that going to be? Well, yeah, I reckon we could just about get away with $90 million. And the dean says, 90 million? Where am I going to get $90 million for a new accelerator? Why? You particle physicists, you always want kit. Why can't you be like the mathematicians? All a mathematician needs is a pad of paper and a pencil and a wastepaper basket.
Yes.
Or even better, why can't you be like the philosophers? They don't even need the wastepaper basket. Right, we have time for questions. Are there any? Right, one there.
Is the future of mathematics mass collaboration, or is there still room for an individual genius?
Probably in between. Most papers nowadays are published with 2 or 3 authors, and it is a definite move from, say, 100 years ago, where the rule was rather single authors. In some fields of mathematics, you can go on to 5, 6. It's very rare to see a mathematics paper with 6 authors or more. It's very different in particle physics. Sometimes you have these papers in which the list of authors is longer than the paper itself. But some more and more collaboration is clearly in the air for various reasons. Also because more often than not, progress arises at the interaction between several areas. In mathematics, you often don't agree about which are the right problems, and it's very rare that you can find many people to collaborate on a single project. And you need a leader at the start with a very excellent vision, somebody like Gowers, probably. It's interesting to analyze the input and the various contributions in the results of this. It's very unequally distributed. You have a few people doing most of the work and many people bringing some small brick to the building in the polymath experiment. It's also interesting, I would say the polymath is also interesting as a study, so to speak, in terms of social science. A little bit like when you analyze what goes on in things like when there was this Kasparov versus the world chess play, and you can ask which is the best strategy to play against Kasparov. It's usually not democratic voting, neither it is a very organized hierarchy, so it's interesting to analyze what will be the mechanisms that arise to the solution of the problem. The polymath may be a model for general forms of organization outside math.
Somebody up there, I think. Hang on.
And sorry,
Yes.
and I must add that, of course, in the field of software, we know that massive collaboration has been there for a long time. It is free software and so on. So you have these thousands of developers sometimes working on projects, and the community has been organized according to rules and so on. But this is a field in which the output is more organized than in math, and output has to work. And this is and has to be checked by many independent looks. So it's a bit different, even though related.
Somebody up there. Yes.
Yeah. Why the spider?
Good. You know, there is not a single day without the question popping out. And I always say, my friend, if I give the answer, it will be no fun. People will not ask the question again. Here, the way it is, they can all go and have this beautiful explanation that I would never have thought about. This, by the way, is beautiful spider made by Tuareg artists. So now I ordered spiders, some people offer to me, and so on. I have more than 30 coming from various parts of the world. One was offered to me in the London Science Museum, with the particularity that it once belonged to a famous mathematician. I took this as a wonderful gift.
I think I was there that day. I didn't offer you the spider. Up there, gentlemen, please.
Hi, I was wondering, seeing the waste paper basket, which is an integral part of doing mathematics, I don't know, do you think it might be replaced by some different computer process? I think of this because Poincaré is supposed to have been the last person who knew all of mathematics, according to some people.
That's correct.
And yet I came across an interactive website doing projective geometry, which I think was the idea that he had on the cliff top that you were talking about earlier. Could it be that there are better visualization tools than a piece of paper?
Maybe, but it's very difficult to imagine. We like, when it comes to communication for other people, we still haven't found anything better than Blackboard. Blackboard and chalk remains the #1 favorite tool of communication for a mathematician explaining to another mathematician, because it adapts to the rhythm of your thought, you adapt to the listener, you can organize it in many ways and so on. And so it's in the way of the idea of representing is a tricky one, very important, but it may be that computer programs might become part of how we organize information of what works and doesn't work and so on. But it's true that we have these visual representations often. It's true. And we see it somehow, sometimes as a kind of maze, in which we are trying to find the way out.
Hi. A lot of mathematicians have been sort of recorded on video talking about the theorem they would like to see solved during their lifetime. Do you have one you'd like to see solved during your lifetime?
One of my very, in my field, I hope I will see the solution of the so-called regularity of the solution of the Boltzmann equation. May not be so sexy stated this way, but this is really important for all areas related to statistical physics of collisions. And I spent quite some time thinking about it to no avail. So it's about whether, more generally, it's part of this problem of understanding the equations of classical fluid mechanics. When you think about research in theoretical physics, you think of boson, Higgs boson, whatever, maybe dark matter, whatever. But we are still helpless in front of some problems in purely classical mechanics. This is water. Look, what I'm doing here is agitating, understanding the statistics of how the movement of my hand is converting into the motion of the water. So-called turbulence problem is a monsterly wide open problem in theoretical physics, let's say. And the problem, knowing if you start from some initial condition with no singularity, whether singularity will occur or not, that's a problem I would really love to be solved. Other problem I will not say I would kill for seeing the solution of, but that the idea is phase transition. You heat this and it will be transformed into vapor. We all do this experiment almost daily when we cook pasta or whatever. But nobody really knows what is going on there. It's a problem of statistical physics of phase transition. It's a crazily difficult problem, can be reformulated in abstract form, crazily difficult. So elusive. People, by the way, think that mathematics is so damn complicated. Mathematicians know it's a misconception. It's the world which is so damn complicated.
Can we bring the mic round here, the gentleman here? Thanks.
I think on my 8th birthday, I saw the film The Living Desert by Walt Disney, and I loved it at the time, so perhaps you should try and find that. One of your earliest pictures was of you, very beautifully portrayed in front of your computer. How much time do you spend thinking, playing, or whatever you would say, on your computer or scribbling on your paper? How does it break down? Do you think a lot, like Stephen Hawking, or do you have to write and scribble and...
I am of the very much writing and scribbling type. And in the it would be in the process of really trying to solve the stuff, most of the time would be on paper. However, as we all know, it is only when you put it into clear form and through computer and so on treatment that you really see where there is a mistake in your reasoning. When you make it in crystal clear form so that the other, your collaborators and so on, for instance, can see it. And so there is it's alternating process, scribbling, putting it in clear form, writing it better on computer, and so forth. Some people use computer for other purpose, like doing simulations, numerical experiments, and getting an idea of what might be true, and so on. I use this a little bit like this, but always having specialists, experts doing the simulations for me. I don't do the simulations myself. And but the scribbling remains the basic activity at the beginning. When it comes to writing, like writing book or text and so on, at the beginning when I started to write, for instance, for Birth of the Theorem, I always, the first chapters, I wrote first on paper before turning them to computer. But then I gradually turned to the habit of directly typing on computer, as many people do when it comes to writing. But mathematicians certainly don't do it directly on computer. They first do it manually in one way or the other.
Lady over here.
Yeah. Hi, Cédric. I was just wondering, noticing that all the questions had a common thread, which is computers or computing power. Now, a lot of people have talked about the second machine age, and I was just wondering, do you see a renaissance coming that, human beings are, literally being freed up from doing more of a mundane work? And if that's the case, how would you suggest, teaching or scaling up creativity for the younger generation?
So the idea being that the machines and computers will do the unpleasant computing tasks and so on, you mean? And then we are free to do the creative business? Yes, some people would also call this rise of the unemployment. So it depends on your point of view, but it's true that globally, story of technologies, you try to make machines and whatever do stuff for you that you would not like to do, and kind of freeing yourself. There are one has to put some warnings there. First, currently it's very clear that the rise of computerization of the whole society is destroying more jobs than it is creating. Many people say it's just transitory, and wait until waves of new jobs, creative jobs, and so on will take over. It's possible, but which is the time scale will make a big difference for the economy and employment rates and so on. And the other warning is rise of computers and machine and robots usually goes into, takes over jobs which are kind of intermediate. The very low-paid jobs usually remain there and are still for humans. There was recently, by the way, this reporting. I don't remember who did that. It was a big of a scandal. That guy seeing what it was like in one of these Amazon's facilities. It was contested by Amazon, but in which really it was humans used as robots. Like there is this watch starting, and you have 33 seconds to go and touch the book and put it there, then another, and doing like this all day long. And this will always, for the foreseeable future, be less expensive to do by humans, very low paid, than by machines. So one has to put warnings in this. But it is arguable that many of the unpleasant tasks can be left to, indeed, machines and computers, with the increase of power and with the increase of artificial intelligence, techniques like machine learning and so on, which enable the computer to learn from experiments, from experience, so to say. And at the level of teaching, yes, that's a key point. How to reform this so that the kids are taught to make the best of what remains the advantage of humans onto machines, and also are taught how to speak with the machine. Speak with the machine means being able to make a program, a code, know what it is like to program some set of instructions, and so on. There is this usual, how you call this, dialectic, but master and servant. And the master becomes the slave of the servant when he becomes unable to perform the task of the servant and to speak the language of the servant, because then the servant takes over. If we don't pay attention, that is exactly what will occur with technology, and we'll become the servants of the technology, slaves of the technology. Part of it is occurring to some extent. But now there is the other dialectic between master and student, which is very different, because when you have master and slave, the master doesn't want the slave to become any learned, to have any education, prevents him from having education. And then the slave gets his own way without communication and so on. But master and student is the contrary. It's like in this talk, student is taught in such a way that he can go and do better than the master. And that's the way one has to think about it. And in this way, you keep the respect of the student also by keeping the contact and the communication. So that's one of the stakes of the modern education, of course.
So what we have to worry about is somebody bringing out a computer called Figaro.
Well,
gentleman up there.
If there was one thing you could change about the education system to stimulate more creativity, I wonder if you have any ideas on that. And more broadly, maybe a bit more difficult question, would there be one piece of advice you would give to policymakers along the same lines?
This question depends a lot on the context. And you saw I gave several ingredients for research. These are and one day a specialist of education, seeing my talk, told me these are also the exact 7 ingredients for education. Particular, the role of constraint, the role of motive, etc. All 7 ingredients are there, and it's a mix of them. If you insist on any one of them too much, it will be disaster. For instance, if you insist on only creativity and not enough on the background and what the knowledge, it will be a disaster. If you insist on only the constraints, it will be a disaster. But if you remove the constraints, it will also be a disaster. So it's a question of balance. And certainly it should not be formalized from above. But here the discussion would be very different in the French and English system. French, certainly what I would say to French policymakers is the key thing is to train the teachers and make them aware of this, and then let them find the solutions themselves. Do not try to impose on them. But here is very different. In UK, there has already been this movement and idea that there should be a lot of freedom in the education, in the schools, and some people say even too much. So the key thing just is It's all a question of mix. And the teachers should be aware of this, and the parents also to some extent. And then let's not try to control things too much. Often I am asked on radio, what is the single most important thing you have to input in? And I say there is no single most important thing. It's all a question of dosing. That's a bit of a problem because it's, for instance, in politics, it's never good to have subtle opinions saying you need this and this and that. It's usually better if you have one single, if you are obsessed with one thing. But that usually doesn't work in real life.
I think this might be the last question, lady up in the gallery.
Hi. What is your opinion on the inevitability of mathematical theorems? How different would maths and physics be today if there'd been no Erdős or no Gauss, no Euler?
Wow. would be nowhere, I guess. So mathematics and Gauss and Euler were both mathematicians as well as physicists. Both very much at ease with very concrete and with very theoretical stuff. So there are examples of the fact that mathematics and physics are very close fields, with mathematics being obviously inspired, a large part of it, by physics, a large part, and physics being transformed by the accuracy, by the precision of power of prediction of mathematics, and also the fact that mathematics gave the formalism with which to exchange the ideas. It is, of course, clear that part of mathematics has never been used by physicists. Some of it for structural reasons, some of it for historical reasons. But also, many times it occurred that a concept developed purely in a mathematical way was applied to change theories of physics. Many people in the audience will know this example, but when Einstein developed the theory of general relativity, we are celebrating the 100th anniversary this year, and he changed his mind about the importance of mathematics in a radical way, saying, before I thought mathematics was exaggerating in its abstraction and demand for rigor. But now I understand that for my theory I need the most advanced mathematics of this day. And this came from precisely people like Gauss and Riemann developing notions, abstract notions of curvature. So a big part of physics would certainly not be there without the mathematical developments. And also there would be problems of communicating and repeating and so on, because mathematics is so good at fixing things and predicting things. Even if you know qualitatively of some effect, if you don't have the tools to make it quantitative and not just qualitative, you will not go very far. So without the Gauss and Euler and others, I think our physics would be in a completely different state as what it is. Of course, there is some gentle battle between the mathematicians and the physicists. The physicists like to laugh at the mathematicians' way, to love rigor and so on. The mathematicians don't like the way of physicists to always do things approximately, whatever. But it's gentle dispute. It's like French versus English. Okay. Okay.